So here, elements of syntax, right? There's always elements of syntax. Main, which is kind of stands out at the top. Main is the name of a function, and this function is by default where the program begins, right? So when the operating system loader component sees this program, loads into memory, it finds main where exactly in memory it gets loaded and transfers control to this place in program, and the program begins to execute, right? So this I told you that main is a function, and technically speaking, function is recognized by the presence of these round parentheses, right? Round parentheses. So round parentheses identify this to be a function because parentheses are used only with functions in situations like this. Functions can have parameters inside these parentheses, but currently main doesn't have any. Opening and closing braces supposed to be specifying the body of the function, right? So this is the name of the function, this is the body of the function. And an opening and closing brace is like a box, right? So when we make a diagram, we place something important inside the box. A way to create a box in syntax, in C, C++ syntax, is to use curly braces. So it's just basically encloses something, making it a single compound item. Inside here, we start writing our statements like this, right? So we can write multiple statements like this, and this is what we can place inside the body of the function, right? So something that ends with semicolon is called a statement. Okay, the statement is an independent item of execution. In our case, you can see that the return statement receives this value from us and finds a way to deliver it to the caller, whoever is the calling entity. Could be an operating system or another program or a batch file environment. Okay. Finally, this int is a data type, means integer, whole numbers, right? Just numbers like 0, 1, 2, 3. This is called the return data type of a function. And when we say return 0, 0 is an integer, and it's supposed to match this. In fact, main, the signature of main function is fixed. You cannot change its return type because the operating system is expecting an integer in return. And right here we have our 0, which matches this return type. Okay, so this specifies the type of the value returned from a function. Okay, so let's make it display something. There is a facility built into C++ library which identifies a standard output device or console window in our case, essentially the window in which program executes and prints something like this, right? So we see this printout inside console window, which opens, or command window sometimes called, right? So there is a device named cout, character output, and you can communicate with this by doing this, by using this type of operator, which called insertion of output. Okay, and we can say hello right here, and we can type text just like this. Okay, if we want to make sure that it appears on a separate line, we can add a new line. Okay. Now, this cout, like I mentioned, this device, which is pre-programmed and available from standard library, needs to be brought into the picture. It needs to be, if you will, the source code for this component needs to be included in our application. And you need to know what specific which specific part of the library you have to use. So normally you can Google this and it'll give you the answer. We will demonstrate this later on, but for now, let's just focus on the code. So I know what brings it into the picture, and you say include IOStream. Okay, so IOStream is actually a standard header inside the C++ standard library, and you bring it in by saying include. Once you say include, IOStream is included into our program. This include portion starts with the pound sign. The pound sign, everything that starts with the pound sign or hashtag nowadays, indicates a directive inside the C++ environment, Preprocessor Directive. So what it does, it gets resolved before compiler, which translates our program into executable code, this text, right? The preprocessor steps in before compiler, and what it does, it resolves every preprocessor directive that starts with this pound sign. How does it resolve it? This IOStream is actually a text file. To demonstrate, if I right-click this, right-click, and say open document IOStream, you see that it actually, hopefully, gets open, and it's a text. So all of this, everything in this file on my system simply replaces this include. So include is a simple text manipulation tool. It goes, finds the file, loads it into memory, and inserts it. Include is gone, and the text is included from that specific file. You can see, I can right-click and even see what's inside that file. That, of course, was brought in and was installed by the compiler. Also, when you start using C++ standard library, everything inside C++ standard library is enclosed in standard library namespace. So namespace is just like a bag of items separated from your own stuff, right? Namespace simply standard library namespace looks like this. You say that cout is a character output device attached to the standard output device stream, and it actually is defined within standard library namespace. So its full name is std : cout. : is actually called scope resolution operator. It basically says this thing belongs to this thing. Okay, in our case, this object cout belongs to standard library namespace. Okay, just a technicality, but altogether this identifies standard output. Why don't we build this? I just go build like this and run it. Once it gets built, you see that by default I display the output window. You may be getting a different view there. You can configure inside Visual Studio where what is the output that you see, but the important part to see is that everything succeeded and nothing failed and so forth, right? So we start making syntax errors. We're going to see error messages down here. Typically I close this panel so that it just like doesn't take too much space, right? And now it's time to run this program. Like this, I just press Control F5, but you can go through debug, start without debugging. You can see that it says hello in the window, and the window displays the program exited with code 0, and we return back to where we started. Right, so all these automatically opening panels I typically close that they don't obscure the view of everything that I need to see. Okay, so these are the components that we have here, right? So once again, this is preprocessor directive accessing IOStream. This is our main function. Our main function has to be present in our program in order to be able to, have program loaded and started correctly. It's a mandatory part. And then we have inside the body of our function, which is outlined by opening and closing braces. All right, we have programming statements. Programming statements generally end with semicolon. You can see that text such as hello, right, just plain text, we can see it gets printed as plain text, nothing fancy, is enclosed in double quotes. Okay, so enclosing it in a single quotes would be incorrect. Okay, so make sure that you select the right thing. And finally, the way we connect hello with character output device, standard character output device, is this output operator or output stream insertion operator, which is actually also defined here in this standard library header. This is defined for this device, and basically when the statement executes, uh, 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 essentially this device finds text hello inside of our program. Also, a note about strings. As soon as you start using double quotes anywhere, in any part of your program, you start using double quotes, and you compile your program, you build your program, what happens is just it gets placed somewhere in read-only memory. So hello is saved with our executable program, and as soon as our program is loaded into memory, somewhere in that memory, in constant memory segment, read-only segment of memory, this text is located, and it becomes available to the rest of the program.